me. But hello, everyone. Welcome. My name is Chris Clark. I'm the Technical Operations Manager for the Cloud Foundry Foundation. Today, I'm very happy to introduce Drew Sonny and Andrew Connolly from Datadog, who will be covering a number of things, but primarily the ways in which Datadog can help you monitor your applications and infrastructure in Cloud Foundry deployments, maybe beyond Cloud Foundry deployments, I'm not sure. So I'll keep this brief. I just wanted to say that we should have about 40 minutes of the main presentation. After that, we'll have time at the end for questions. So throughout the session, please put any questions you may have into the Q&A. If you have any technical issues, reach out in the chat. So very happy to have Drew and Andrew here today. Excited about Datadog's platform. So without further ado, metrics, tracing, logs. Oh my.
Let's do it. Thanks, Chris.
Great. Thank you, Chris. So yeah, welcome everybody. We are here today to talk about monitoring Cloud Foundry. And so, yeah, let's jump right in. So I think we probably all recognize this on some level, but I want to restate it here. No matter how careful or prepared we might be, issues are going to occur in production. And so how do we respond? How do we handle this? Well, we want to watch our platforms and our applications closely. But unfortunately, you know, a standard telescope, just watching isn't enough, right? Cloud Foundry is very powerful, very robust platform, but it's complex. And so to account for all this complexity, we want to go beyond just watching, right? We want to monitor. And so that's what we're going to talk about today. We're going to talk about really unlocking the ability to monitor Cloud Foundry. So a little bit about where we're coming from in terms of how we built this presentation, how we thought about our audience. So we're thinking that you are involved with Cloud Foundry somehow, potentially developing applications that run on Cloud Foundry. Maybe you are an operator administering a Cloud Foundry deployment, or maybe you're just some other key stakeholder in the mix, someone who owns a service that runs on Cloud Foundry, someone that owns you know, an IT department that has some Cloud Foundry footprint. So that's kind of where we're thinking you're coming from, and a little bit about us. So who are we? I'm Andrew. I'm a product marketer at Datadog, and I'm joined by Drew, who is a product manager at Datadog with an emphasis on all of our integrations, tools, and libraries. And so as we are from Datadog, I think it's relevant that we give you a quick 90-second background on what Datadog is if you're not familiar. So Datadog is a SaaS monitoring and analytics platform that will provide full visibility across any stack into any app at any scale. Really, as we saw on that DevOps slide a couple slides ago, the goal is to unify stakeholders, whether you are an ops, whether you're an app developer, whether you're a business stakeholder, maybe even a security team nowadays. Datadog wants to bring you all together and give you a single source of truth for monitoring your applications and environments. Whether that's from the infrastructure level all the way to front-end use cases, understanding your user's digital experience. And so one of the ways we do that, one of the ways we bring together all these different stakeholders and all this different data is by supporting almost 450 out-of-the-box vendor-backed integrations. So these are just a few of them you're seeing here on the screen. These are all integrations that Drew's team has built and support with great depth and breadth. And really the idea behind all these integrations is to solve for a lot of the complexity. So I referenced complexity early on, and this is one of the ways we're trying to tackle that problem. And obviously, because we're here today, you might suspect that Cloud Foundry is one of the 450 in our toolbox. And so that's where we're going to focus today. And then once you have all this data into Datadog, it's really about connecting it all, making it easy to move from your metrics to your traces to your logs, like Chris mentioned at the beginning. We really are about unifying everything, organizing all that data in an intelligent way, and then making it usable for your entire teams. Another theme we'll probably hit on a few times is Datadog wants your whole team to be able to use the platform and to learn the platform quickly. We're not trying to create silos or subject matter experts. We're really about ease of use and access for everybody. So that's a little bit about Datadog. So here's the agenda for today. We just hit the why, the who, and the Datadog. And then we're going to move on now to talk about Cloud Foundry under the hood. We'll do a little bit of level setting, so to make sure everyone kind of understands, or has a baseline for what we're talking about. And then we'll do kind of the same thing with monitoring. I tried to set up that contrast between watching and monitoring. And so we'll talk a little bit about what we think of as the baselines or the basics for monitoring. And then we'll start to layer the concepts on top of each other, talk about monitoring Cloud Foundry, talk about Cloud Foundry and Datadog. And then we'll wrap up with a little demo where we talk about actually monitoring a Cloud Foundry application with Datadog. So that was a lot. I'm going to pass it over to Dhruv now, who's going to talk in a little more depth about what's actually happening under the hood with different Cloud Foundry components.
Great, thanks, Andrew. Hi, everyone. My name's Dhruv. I'm product manager for integrations at Datadog. So in this section, I'm going to basically, like Andrew was mentioning, just level set and set a baseline of knowledge, since we'll be talking a lot about the key metrics, what kind of logs you should be collecting from Cloud Foundry. And there's so many moving pieces. We realize that although most of the audience here would be attached to Cloud Foundry in some way, you may be coming from different backgrounds, right? You might be a developer, all you've done is interact with Cloud Foundry through like a CF push command, or perhaps you actually are an admin, you are an operator. Hopefully this section is still useful for you. But yeah, in the interest of time, we'll be only covering high level topics, as of course we can go way deeper into this. For anything extra, if you have any questions, please leave them in the Q&A section. Okay, so let's dig in. The very first component in Cloud Foundry that I want to talk about is BOSH, right? There are a lot of moving pieces into Cloud Foundry in this diagram. I've kind of separated this into layers, right? So we have separate layers that Cloud Foundry has. BOSH encompasses all of this. It's not really a layer, but it's a deployment manager for VMs, as well as third-party software on Cloud Foundry. So since Cloud Foundry is an ecosystem of these services working together, BOSH actually is used to install all of these different services, no matter which cloud provider or virtualization technology that you're using. Its primary job is to install and manage the Cloud Foundry components, but you can also install things like the Datadog agent, which is third-party software through it. I guess the main component of BOSH that you would want to monitor is the BOSH director, and that's kind of where you would upload all of your automation scripts to, otherwise known as BOSH releases. And the BOSH director really is kind of like the brain of the kind of BOSH setup here. So let's start with the first layer of Cloud Foundry and then go down that stack. The very first layer is the routing layer. And in this layer, you have the router, also known as the Go router. And its main purpose is it handles and routes incoming requests. And these requests can be developers pushing apps, so that CF push command, for example, or it can even be operators performing administrative tasks, or it can even be your end users, right? Actually accessing the applications on a specific Cloud Foundry deployment. All these routes essentially go through the Go router. And it also provides very basic load balancing. So basic round robin style load balancing that is available for your application, so that if you scale your applications into multiple app instances, it handles that the load balancing for you. The next layer is the user authentication and user account and authentication, excuse me, or UAA server. And this layer basically provides the identity and access management to Cloud Foundry. So anytime you actually issue a CF command, you first actually have to authenticate. And this is the server or the layer that actually does that authentication. If you want to leverage OAuth 2 for your CF apps, you can also, it also has OAuth 2 built in, so you can utilize this for OAuth 2 authorization as well. So going further down, we have the app lifecycle layer. And in this layer, I'll talk about the primary kind of components that are more relevant to this presentation. The first one is the Cloud Controller API, also known as the CC API for short. And essentially, the Cloud Controller API contains endpoints used to interact with all the various CF components you see in this diagram, and as well as all your applications as well, right? It's the primary interface to Cloud Foundry. The next thing as part of this layer is also pretty important. It's called cell rep. And a cell rep basically reports the state of your garden and Diego cells. And I'll talk about that in the next slide in more detail. But essentially the rep reports the state of your Diego cell, which creates and manages the actual containers. And the reps report includes statistics on what's available, like all the different resources that are available, so that these metrics can then determine if your deployment has adequate capacity for your applications or if it actually needs to be scaled. Okay, so now going even deeper into this into the stack, this is the main kind of meat and potatoes layer of Cloud Foundry. This is the app storage and execution layer. This is where all your Cloud Foundry applications actually run. So the main component in this layer is Diego. And Diego is essentially the main container orchestration system. It also has a blob store attached to it, which I'll talk about in a second. But essentially Diego encompasses the Garden API, which is the container runtime that your apps run in. And the blob store that is attached to Diego is used to actually store all the generated binaries when you do a CF push. So every time you do a CF push, essentially in a nutshell, what happens is your application files are packaged and put on the blob store into immutable artifacts, so that if you ever scale in future, if you ever scale into multiple app instances, you constantly don't have to redo CF pushes. It's using the artifacts in the blob store.
Dhruv, I have to jump in and ask, who is Diego? Why did he get the special privilege of having his
that's a good question. So, for longtime Cloud Foundry users, you might be already familiar with this, but essentially Diego replaces the droplet execution agent, also known as the DEA, and it's written in Go. So hence DEA Go. There you go, some Cloud Foundry history for you. But yeah, so besides just the Diego component in this layer, there's also another notion of different app types that I want to touch on real quick. So there are two app types inside Cloud Foundry, tasks and LRPs. Tasks are essentially very short, finite processes that you run on Cloud Foundry. So examples of this could be, let's say, a database migration, or if you're running a batch script or backing up some data. Essentially, you're expecting this process to end. An LRP, or a long-running process, is essentially what it sounds like. It's a longer-running process that doesn't necessarily have a finite end. And the most typical example for an LRP is your app, right? You would run your app, and that's classified as an LRP app type. All right, so the messaging layer. In the messaging layer, the most important component is the bulletin board system, also known as the BBS. And the BBS is the intermediary between the CC API that I spoke about earlier and Diego. So it provides an API to communicate with and sends requests to the Diego cells. It also functions as a gateway through which information about desired LRPs and actual LRPs flows. So it's, as you can imagine, vital to maintaining an accurate picture of your Diego cluster. In order to make sure that it's in a proper state at any given time, it also does a consistency. So it runs these convergence assessments routinely to compare the running state on the Diego cells against what's the desired state. So you might want, let's say, a replication factor of 5 for your app instances. It's constantly checking to ensure that the replication exists. All right, last but not least, this is the most, I guess, relevant section or layer to this presentation. And this is the metrics and logging layer. And the primary component in this layer is known as the logregator. The logregator aggregates and streams both logs and metrics. So unlike the name suggests, it also actually encompasses metrics as well. It includes component and host VM data. And I'll talk about the differences between component and host VMs in a later slide. Essentially, it captures all these logs and metrics and makes it available for consumption through something known as Firehose. And Firehose is a WebSocket endpoint that external clients, such as the Datadog agent, can connect to. Okay, so that was a quick whirlwind tour about basically all the different moving parts, all the components under Cloud Foundry. And with this, I'll pass it back to Andrew, who's going to jump in and talk about how to approach monitoring in general.
Awesome. Thanks, Drew. So yeah, again, want to do a bit of level setting. And so that's we'll spend a minute or two here talking about different frameworks or approaches to monitoring. And so on the next slide, you'll see the framework that we've proposed or that we're referencing here. And really, it's important to remember there is no single right answer here. There is no perfect way to do this. But we do think that for any kind of troubleshooting, it's important to have a guide or a framework or a map to help bring a little bit of order to chaos. And so here we're talking about work metrics, resource metrics, and events. And so one way you can think about this, work metrics are the top level end user facing metrics, things like throughput, success and error rates, performance or latency measures, things that measure the top line objective of whatever your service or application is. Resource metrics go a level deeper, and we're talking about the availability of your underlying resources. Do you have the CPU, the memory, and the disk necessary to do what you need to do? And then alongside those, we have events, which can really be, if you think of resources underneath work metrics, events can run alongside and tell you all the config changes, the start stops, the alerts, the scaling events, kind of all the discrete markers of activity happening in your applications and systems. And so on the next slide, we'll see a fun representation of how this framework can be kind of nested or recursive on itself. And so if you think about, especially in our modern dynamic environments with tons of different services communicating with one another, oftentimes a service's customer is not an end user, is not a business person or a customer, it's just another service. And so oftentimes the resources of your top level service are going to actually tie to the work metrics of the underlying service. And so you can see how you kind of get this spiral all the way down. And so this is the idea why it's important to have a framework. It's important to have a way to structure your investigation. And so again, that's what we're trying to do with the work, resources, and events framing. On the next slide, we'll talk about how we can think about these different data types. And so at the lowest level, there's really two types, right? There's time series metrics, which are just numbers with tags. And then there are logs, which are just strings of text. Those are kind of the core pieces that are going to make up any type of monitoring data. And then as you think about different use cases, different things you want to monitor, different monitoring tools, you get these higher level abstractions that are really just based on different combinations or types of time series or logs data. So that might be discrete events, that might be distributed traces represented in a flame graph, that might be network flows, might be the results of a synthetic test. And then really on top of all that, you have alerting, which again, just another type of event. And so you can see, and you will see as Drew begins to go into the Cloud Foundry monitoring fundamentals, that we're always talking about either metrics or logs. And while it may seem more complicated or sophisticated for specific use cases, it's really all built on these metrics and these logs. And so what should you actually monitor? Again, if you think about our work, resource, and events framework, this is really the same thing. You have your platform. So in this case, we're talking about Cloud Foundry. This is the building block. This is the foundation of your house. And so problems in your foundation, they might not feel like crises right away. They might not feel like emergencies with big flashing red lights, but cracks in your foundation will eventually destroy your building, right? You don't want your foundation to crumble. And so that's why you have to take care of your platform. And then the application, this is more the work metrics, right? The end user's experience or the customer's experience. How often are they succeeding in whatever their objective is? And so those are all the things that Drew is going to unpack now as he moves on to talk about monitoring Cloud Foundry.
Great, thanks, Andrew. So hopefully by now you've gotten a real quick understanding of the Cloud Foundry components that exist, and there are a lot of them. and kind of how to approach troubleshooting through the work versus resource metric framework, right, that we just talked about in the earlier section. So now let's connect the two together, and let's dive into what kind of key metrics you should be alerting on, or at least have visible inside some sort of a dashboard, right? We'll start off with the layers approach that we took earlier. Okay, so starting with Bosch. Now, with Bosch, since it's really an orchestration tool, right? So like a Bosch agent would run on every single VM, ensuring that it's deployed correctly and that the required software that you're trying to install is installed. It's not necessarily Bosch that you're monitoring, but it's essentially the VMs that Bosch is running on. So the goal here is you want to make sure that your underlying CF VMs are healthy and that they're running as desired. What I mean by that is that they're performing their intended purpose, right? So if the VM is, let's say, part of a Diego environment, you want to make sure that it is up, healthy, and serving its Diego cell. If it's part of the UAA server, you want to make sure that it's obviously running the processes and components in order to make sure that it's authenticating properly. So the basic VM metrics that you would want to monitor are probably not a surprise to most of you. So the first three, starting from the top, the first one is system healthy, and this is essentially just a simple health check. That's available to you. If it returns 1, that means that the VM is up, all the processes are running, and 0 if it's not. And this is a good example of a resource metric. It's an availability metric in particular. The next one that you want to keep an eye on is the percentage, the CPU percentage. And this is really important when you want to troubleshoot why something related to throughput is essentially higher than normal. CPU very most likely is the culprit for that. So you want to keep an eye out on CPU, system CPU specifically. And then the third one is obviously memory as well, right? So similar to CPU, the level of available memory on the VM is, if it's too low, the process might suffer, right? So keeping an eye on this is also going to help you determine if the VM needs to be scaled up, if you need to add more resources to it, or if you need to scale horizontally, if you just want to add more VMs and more instances to that. Okay, so this was pretty basic. So let's look more deeper into specific metrics for each component, starting with the UAA server. So if you remember, the UAA server is responsible for identity and access management. The goal here is to ensure that the UAA server is keeping up with the authentication request volume. A lot of the times, this could be your bottleneck along with the router, which we'll talk about in a second, because essentially these two servers, every single request has to pass through, right? These two services. So you want to make sure you're keeping an eye on these following metrics. The first one is requests global completed count. This essentially is the lifetime number of requests that the UAA has handled. If you take this metric and you plot it as a rate on a graph, so either per second or per minute, it'll help you identify unexpected spikes, or more commonly, unexpected drops in the UAA server. And that's obviously alarming, right? So you want to keep an eye out on that. The next one is the server in-flight count, and that's the number of requests that the UAA is currently processing. So again, similar to the request global completed, you want to plot that on a graph and keep an eye out for any spikes or drops and set alerts accordingly. Now with the router, since it's the entry point for all the requests, and it maintains a dynamic routing table tracking which containers on which cells are running so that applications can then forward those incoming HTTP requests appropriately. This is a pretty vital part of Cloud Foundry, right? So you want to ensure that the router is handling requests successfully, and more importantly, or equally importantly, timely, right? So again, it could be a single point of failure of your entire Cloud Foundry environment. So you want to make sure that it's always healthy. The most important metric probably for the Go router is your latency. And that's the average round trip time, measured in milliseconds most commonly, for requests to go from the Go router to the endpoint, which is an application or a component API, depending on the request, and then back again. So obviously increases in the time it takes for this request to complete can result in catastrophic failures down the line, right? So you want to keep an eye out on this. If your Go router latency is especially high, it's useful to correlate with the CPU utilization that I was talking about earlier, because essentially it could be a resource bottleneck that you might want to either scale up or horizontally. We recommend starting with an alert on the Go router latency of 100 milliseconds as a starting point. And then as you kind of continue your monitoring journey with Cloud Foundry, you can fine tune this and fine tune your alert threshold accordingly. It'll depend on your deployment size. Okay, so the next one is the responses 500 series errors. And these are the lifetime number of specified HTTP server responses. So these could either be 500 or 503, et cetera. These are indicative of backend failures. So you want to keep an eye out on 500 errors, because again, this could basically mean there's a failure on the backend that the Go router is only surfacing now through this metric, but the failure could be deeper. And similarly, the milliseconds since last registry update. So this is basically the amount of time in milliseconds since the last route was registered and was received and emitted by the Go router. This is another similar to latency, where you're trying to keep an eye out on whether your requests are being handled in a timely fashion or not. All right, so we'll move to Diego now. So Diego is, if you remember, like the main kind of environment where your applications run, and within it, your garden runtime actually runs within it. But before we get to the key metrics to monitor for Diego, real quick overview of the structure of how Diego talks to the different components, right? So from this diagram, you can see that Diego is on the right, and on the left-hand side is your Cloud Controller API. So essentially, there's a lot of syncs that happen, a lot of syncing. So from your CF apps, the very first sync is to BBS. The bulletin board system, if you remember, does the convergence. It constantly ensures that your desired LRPs and your actual LRPs match, right? So your desired state matches with what's actually running. And it gets the data of what's actually running from the cell rep. So the cell rep is kind of the representative in a way of what's running inside your container, and it provides that information to BBS. And essentially, BBS is keeping track of these two things. So when you're monitoring Diego, it's essential to monitor all the different components within Diego. It's not just the one thing, right? Which is what this diagram is trying to convey. So what's our goal here when we try to monitor Diego? Well, we're trying to ensure that all the incoming requests are assigned correctly, first of all. Second of all, they're not resource starved, right? So you're not running out of any resources. And third, the correct number of instances are running at any given time. If you've set a replication factor of, let's say, 10, obviously you want to ensure that 10 instances are always running at a given time, right? So again, this is just a high level. There are a lot more metrics that you should be monitoring, and we'll post a link towards the end of the session on our blog post, which goes into much more depth. But essentially, you'd want to keep at least one metric for each subcomponent of Diego. So as an example, one subcomponent is the auctioneer. And at a very high level, the auctioneer basically takes care of the auctions process of Diego. So basically, Diego tries to figure out how much resources it should sort of spend on a given app instance. So for the auctioneer, the LRP auctions failed, or even task auctions failed, it's a very similar metric, is probably the most key metric you want to monitor on. So this is the lifetime number of LRP or tasks that the auctioneer has failed to place on cells. Similarly, for LRPs missing, you want to keep track on this, because any missing LRPs, which is a mismatch in the BBS level, you want to get alerted immediately. That means something's going wrong. The BBS can't really ensure the desired state, which is a problem. For unhealthy cell, the Diego cell health check, this is again a very simple health check, 0 or 1. This will tell you if you have multiple Diego cells, as is very common in Cloud Foundry deployments. If you see a very high number of unhealthy cells, that means something's up, right? Like something's wrong. Either your BOSH deployments are failing and the Diego cells aren't able to spin up in time, or there's something underlying with the virtualization there. If you're running on something like vSphere, something's wrong at that layer. Then lastly, for active locks, this is a metric that's emitted by a subcomponent known as locket. And essentially, locket is basically the service that ensures all the different locks are placed for the Cloud Foundry component so that they don't run into race conditions. Locket generally has about 4 active locks at a given time. So if you notice that number of locks falls dramatically into something like 1 or even 0, that means something is definitely wrong with not only Locket, but now you have to go downstream and see what, because of the failed locks, what kind of problems might have occurred, right? So that's another one you want to absolutely keep an alert on. Okay, so the next component we'll want to monitor is logaggregator, right? So you're actually monitoring the monitoring component in a way. And just if you think about it, it's really important, right? Because if the monitoring component itself goes down, you're kind of blind, you're flying blind. So it's essential to monitor logaggregator. And this diagram is trying to convey that logaggregator is not just one thing. It's not just like one service that runs. It's actually a combination of different things. And the different components, essentially, I'll talk about it in a second, but they are all tied together. It's a path or a chain. And within this chain, there's a concept of a message that gets flowed through. Essentially, a message is just a convention that Cloud Foundry has set for things like logs, and they're standardized as envelopes. So that's the convention. And essentially, this is because if you're using a third-party tool such as Datadog, right, you know how to parse it. You know how to parse that information. So what components are part of logaggregator? Well, there's 3 essential components. The first one is called the Metron agent. The second one is the Doppler server. The third one is the traffic controller. So the Metron agents basically run on all the different VMs, and they are responsible for collecting metrics. So if you recall, I talked about component and host VMs earlier. So the difference between them is pretty straightforward. Host VMs are the ones that actually host your containers. So essentially they're DAO cells. They run all the different Garden runtime components, versus the component VMs are the VMs that actually host your Cloud Foundry specific services, right? So the reason there is a distinction between these two will become more clear in the later slides, but there's slightly different ways to monitor these two. But for now, just know that Metron agents run on all these VMs and do the collection. Once they've collected the required metrics or logs, they then forward it to Doppler servers, which are responsible for aggregation. After they've aggregated all these different messages, they then forward it to a traffic controller, which consumes it and then further exposes it through Firehose, or there's different ways to expose this data, which we'll cover, but essentially Firehose is the main one. You also have things like syslog, drain, and log cache. Okay, so that out of the way, hopefully you have realized that logaggregator is not just one thing, it's multiple components. Let's look at what you should be monitoring for logaggregator. So the goal when you're monitoring logaggregator is that you want to ensure the entire logaggregator chain is passing messages successfully and timely without delay. So the top 3 key metrics essentially are all very similar. You want to be catching dropped messages. That's the theme here. So on the logaggregator component, specifically for Doppler, there's a metric called Doppler.dropped, which is essentially the lifetime number of messages dropped by Doppler. For syslog, it's similar, it's adapter.dropped, and then for the logaggregator's RLP, or the reverse log proxy, it's RLP.dropped. So for all 3 of these, and if you're wondering, by the way, what reverse log proxy is, that's essentially application logs. So not the component logs, but logs from your application. But for all 3 of these, you want to at least have these on a dashboard somewhere, and you're looking for spikes, right? You're looking for a huge increase in dropped messages, because that's going to be a problem. That's going to be a blind spot in your monitoring. You want to then go back and see maybe if it's an issue in networking, or if it's an issue on resources that you might want to add and ensure that logaggregator is functioning correctly, right? Okay, so far we talked about key metrics for all of these components, but the next question you may have is, what about logs, right? Logs is obviously very important to collect as well. It provides another dimension to troubleshoot. Metrics is only 1/2 of that coin. You have more than one option available to collect these CF logs, depending on the log message type. So if you are trying to collect platform component logs and metrics, actually, the access method is going to be Firehose. If you're trying to collect application logs, you have a few options available to you. It can be through Firehose. It can be something through something known as a log cache or a syslog drain. And then for system component logs, it's essentially just the syslog drain, or you can directly actually collect the logs from the component VM if you're using third-party monitoring tools, right? If your monitoring tool has an agent, in the case of Datadog, there is an agent. It's called a Datadog agent. You can actually install it directly on your component VMs so that it collects it directly and you don't have to go through syslog. So let's actually take a look at this in a little bit more detail. So yeah, before we do that, just to make that distinction more clear, the Firehose sits right here, right, after their traffic controller. And the syslog drain is also available through the traffic controller here. But in the case of your component VMs, if you don't have any third-party monitoring tool running on these VMs, the only option available to you is the syslog drain directly. This does not go through the Firehose. So just keep that in mind. Okay, so how do you actually collect or interact with the Firehose? Well, you have options for that too. The first option you have is the command line. And you might already be familiar with the CF command line tool, right? So the CF CLI actually is plugin based. You can install community or third-party plugins to it. The most popular plugin for communicating with the Firehose is CF Nozzle. The CF Nozzle plugin is great for quick validations. Let's say you just deployed an app or you just scaled up a specific component and you just want to look at the logs for it. It's a very quick way to stream the logs through the Firehose. It's not a good way to actually monitor your Cloud Foundry environment, right? Like you don't want to just have this command line going and outputting in standard out and then put it on a screen somewhere. That's not a good use for it. There's actually better ways to do this. The better way would be through a nozzle. And a nozzle is essentially just a piece of software that knows how to interact with the Firehose endpoint. There are many third-party nozzles out there. One such nozzle is, of course, the Datadog nozzle. And these can be installed either through Bosch directly if you're using open source Cloud Foundry, or if you're using the VMware or Pivotal flavor of Cloud Foundry, you might have Ops Manager installed, and you can install it through the Opsman tile as well. And then lastly, again, if you're using VMware, Tanzu, or Pivotal Cloud Foundry, you have something known as HealthWatch that is an add-on service available to you. And it's basically essentially a UI that displays these metrics, right? So what is the log cache? The log cache is a component that's co-located on the Doppler servers that duplicates and stores the information coming in from Logaggregator. So unlike the Firehose data, which is essentially just streaming data, right? The log cache actually stores and persists data. So you might want to actually query historical data. You can do that through the log cache. Note that this actually needs to be enabled. So by default, it's not part of a default installation. You actually have to enable it through Bosch. Or if you have Opsman, it's under the advanced options in your deployment tile. So how do you query the log cache? Well, you can use the command line. It's useful for quick validations. The plugin is called log cache plugin. And the way to use it is through the CF tail or CF query command. And the log cache also provides a RESTful API. So it actually supports Prometheus compatible endpoints. So if you're using some sort of a Prometheus scraper, you can actually directly tie into log cache.
Hey, Drew, quick question for you.
Yeah.
Why would somebody choose the log cache over using the Logaggregator?
Yeah, good question. So the log cache, essentially, its main value prop is the persistence of data, right? So if you're streaming data into something like Datadog, you most likely will use the nozzle because you're streaming data and all that history is stored in your monitoring tool, right? So Datadog will actually have that history for you. Log cache is useful if you want to actually run queries against your historical data directly inside Cloud Foundry. So you might run the CF query command as an example, which lets you structure PromQL statements directly to log cache. So again, it's an optional component, and depending on how you're monitoring Cloud Foundry, it may or may not be needed for your use case. Okay, and then the third way that we talked about ingesting monitoring data was the syslog, right? The syslog essentially is just it's a protocol that is very common in the logging industry. And it has the notion of syslog adapters, which are essentially just third-party clients that recognize the syslog format, right? So you can either use those syslog adapters, or again, the command line is always an option. There's a CF drain plugin that's available to you. And it's, again, used for quick validations. You can actually see what's coming in through syslog in standard out, or maybe you can dump it to a file to share with your coworkers. Okay, so that was a lot of information, right? Like I was just throwing a ton of information out at you. This may be new, this may not be new, but the point, hopefully, that you've realized by now is that Cloud Foundry is complex. You know the key metrics to monitor, but you have many options on how to get those key metrics. And there's a lot to do, right? So I want to talk about the Datadog Cloud Foundry integration. Essentially, this makes it all easy. All the complexity that I just talked about, it actually makes all of this very straightforward to collect. It brings together all these three pillars: the metrics, the logs, and even tracing, which we haven't spoken about yet. But it brings all of this into just one platform and one view. Some of the features that we have, so we have automatic installation of the cluster agent, as well as auto discovery of all the different integrations. So you might be running services like MySQL, Redis, Nginx, whatever. We can auto discover all of that. You can correlate across metrics, traces, and logs, not only from Cloud Foundry, but all your different applications. It also includes out-of-the-box dashboards and recommended monitors. And we also have audit events. We have live containers so that you never actually have to run the CF apps command ever. You can see all your Cloud Foundry apps through a UI. And then, of course, we have alerting, right? Because you want to get paged and proactively set these things up versus just dashboards. So if you actually install the Cloud Foundry integration, you'd be greeted with a nice, pretty looking dashboard, something like this, which comes out of the box. You don't actually have to set this up yourself. And then lastly, the way that you install the integration is also pretty straightforward. If you're using open source Cloud Foundry, it's just through Bosch. So we have Bosch releases for the cluster monitoring tile that you can install. Or if you're using Opsman, even easier, it's just UI, click the tile, and you're done. For application monitoring, we have a build pack that we distribute. And as long as you attach the build pack with your app deployments, you'll get a lot of things. You'll get tracing, you'll get the logs forwarder, and you'll get that auto discovery for integrations that I was talking about earlier. Okay, so right now we just kind of focused mainly on the platform monitoring, right? So we talked about like key metrics, logs for platform, but what about your CF apps? Well, for CF apps, real quick, you have a few options on how you want to monitor your apps. So the first is obviously Logaggregator, as we spoke about. Although for this one, you actually have a choice. You can either you can actually send all your application logs and metrics to Logaggregator, or if you're using something like Datadog, you can use the native integrations. And there's some advantages to using the native integrations. For example, native integrations are auto-discovered, so it eases setup. And also, there's a lot of out-of-the-box functionality that you'll get with these integrations. So for example, I was mentioning the out-of-the-box dashboard. Well, we have out-of-the-box dashboards for all our Datadog integrations. So you'll get that pre-installed, whether you're monitoring Nginx or MySQL, whatever. The next thing you want to do with your applications is you want to trace them. And this is essentially sending different spans into Datadog so that you can outline that, you can plot them out into a flame graph and essentially figure out where your errors are at the application level, right? So not the platform level, but actually at a function, method, or database level. And then lastly, of course, you want to set up your application logs so that they forward to Logaggregator. Although for this one, you also have a choice. If you don't want to do the forwarding to Logaggregator, you can also include the Datadog build pack and have Datadog forward the logs directly to Datadog. So the best way to illustrate this is probably through a working example. So we have a very simple example to walk through here. We have a two-tiered app, two containers. The first container essentially runs just Nginx, which is set up to be a reverse proxy to forward all the incoming requests to the second container. So second container is just a simple Sinatra web application that includes the Ruby build pack. Okay, so let's have a look at what that looks like. Essentially, this is what it looks like, right? So we have the Sinatra web app just serving this very simplistic web page. So as we expect with Cloud Foundry, if we refresh this, it should continue working. Oh, okay. Looks like there's an error.
Sorry,
well, this
Drew.
is a live demo.
I was doing a little multitasking and I may have fat fingered something. Sorry about that.
Well, okay. No pressure, Andrew. This is just a live demo. So, let's troubleshoot this together, right? We just talked about monitoring. Let's use our knowledge to actually figure out what went wrong, right? So in a situation like this, where you don't really know where to start, the first thing you would do is you would go on to your dashboard. And since we're out from Datadog, obviously, we're going to use the Datadog platform to outline this. Here's the dashboard that I was showing you earlier in the screenshot. And you would start off with the dashboard. And I'm going through the dashboard. I'm just eyeballing all the different key metrics that we talked about, right? So Diego status, processes running, the Go router, everything seems to be fine at first glance. So what else could it be? Well, we might want to take a look at our specific Nginx section that I've added to the dashboard here. And sure enough, if I expand this graph, we'll see that, well, up till now, we were getting all 200 responses, right? Which is the purple. But starting from about a minute ago, when I refreshed the page, we started getting 404s. So that's interesting. And there's also a pink line that you can see that's overlaid on top of the graph. And this pink line designates that some sort of an audit event happened. And it's pretty suspicious that an audit event happened right about when the 404s were occurring. So what I'll do next is, since the Datadog integration ingests audit events, I'll switch over to our event stream. Now, our event stream, if I just refresh the page, should outline what the audit event was. Here we go. So sure enough, an audit event occurred, and it looks like, yep. So Andrew, the admin user, actually ended up stopping my webinar Ruby app. Thanks, Andrew.
I meant to redeploy. Sorry about that.
No worries. So now we're going to use Datadog to ensure that we can actually have this running again, right? So let's keep our event stream open while I quickly restart this app. And also, just to illustrate a point further, when I refresh this, you'll notice that in the event stream, my monitor also triggered. I had a monitor here from before this, this demo that essentially I put on anytime that there is more than a couple of 400 series alerts within the last 5 minutes that it would trigger. Okay, so I just restarted my app. And if I refresh my app stream, you should be able to see another audit event just to confirm that, yes, I have indeed restarted my app. And at this point, I could also do a cf apps command just to see that my apps are running. But if you have Datadog, we actually have a live containers view, which is super helpful. So in this view, I've already filtered it down to the word webinar. So you'll see my 2 containers, which are called Webinar Nginx and Webinar Ruby. I can actually click on an individual container and see the processes running within that container, which is pretty handy. I'm just going to refresh the page real quick since we noticed that the, yeah, so this is basically essentially just my older container that was running. Okay, great. So just to verify, the app is indeed running. Okay, so real straightforward, simple demo. So what happened, our Ruby app was accidentally stopped. The troubleshooting steps that we took, we went on to the out-of-the-box dashboard, which outlined all those key metrics, right, that I was talking about earlier during this presentation. We also noticed that a triggered monitor gave us further clues as to what might be going wrong. The logs then, so basically the 404 and 200 series metrics that we had were actually generated on the from the logs, the Nginx logs. And the event stream then clarified and confirmed that indeed the CF app, the Sinatra app had been stopped. And then we used live containers view to just verify that the app was back up and running. Okay, So with that with that demo, I'll pass it on to Andrew, who's just going to wrap this up.
Awesome. Thank you, Drew. You covered a ton of territory there, but I hope everyone found it informational and educational. So yeah, just a brief recap. We started out by trying to level set, talking about CF components, highlighting the important ones and how they fit together, also talking about some monitoring 101 concepts, throwing out an example framework with the work and resource metrics, talking about different monitoring data types, and then really layering them on top of each other to understand what does monitoring look like in Cloud Foundry, what are some of the challenges and pitfalls. Obviously, it is complex, but that kind of goes hand in hand with the power of the platform. Does come a little bit of complexity, but we think there are a lot of ways to solve for that, and Datadog is a really good way. And hopefully you learned a little bit in that live demo there. Drew was very quick to fix my mistakes and to get us back on track. But yeah, we thank you all for joining us today. We have a few minutes here, 7 or 8 minutes. So if you do have any questions, please feel free to use the Q&A functionality. And if it's a nice question that we can kind of share with the whole group, we will. If it's a more pointed question, we can reply just via chat. But yeah, thanks so much.
Thanks, folks. We'll stick around for questions.
Yep, absolutely. And I'm going to paste a few links here in the general Zoom chat. So if you want to go deeper, you'll have these links. Drew mentioned our blog series, which a lot of this content is drawn from. And we get very granular about things you might want to alert on, detailed lists of metrics to monitor. So a really, really nice resource.
Thank you, Drew and Andrew. That was great. I really appreciate the thorough walkthrough of Cloud Foundry components, Bosch, and the deep dive into Logarithm. That was great. We've got a couple of questions. How does Datadog compare to HealthWatch?
Yeah, I can take that one. So HealthWatch, just to recap, is one of the add-on services that comes with if you're using VMware Tanzu application services or Pivotal platform, depending on the release version. HealthWatch is actually pretty useful. A lot of our customers are running both HealthWatch and Datadog. HealthWatch obviously is focusing on just Cloud Foundry, so it's a good resource to plot different key metrics that I was mentioning in this presentation. But a lot of our customers find it valuable to use Datadog just because of context, and that's really the power of monitoring, right? So what I mean by that is you might not just have a Cloud Foundry environment. You might actually have a mixed environment, a hybrid environment, and for that, Datadog's great for that because you can actually see all your Cloud Foundry metrics in relation, how they kind of correlate with your non-Cloud Foundry components. In addition to that, you might also be using things like real user monitoring or synthetic testing or even tracing, which are obviously gaps on the HealthWatch, right? So yeah, long story short, if Cloud Foundry monitoring is the basic type of monitoring that you need, you can set that up. But the caveat is that you also have to make sure that HealthWatch itself is up and running, right? So there's some maintenance work there.
Great, thanks. Another question, are there any functionality differences related to the integration to be aware of between open source Cloud Foundry and VMware Tanzu application service?
Yeah, that's actually another good point. So the integration itself doesn't really distinguish between flavors of Cloud Foundry. It should work as intended. All the metrics should be the same out of the box. What would differ is the deployment strategies, right? So I mentioned a couple of times during this presentation that if you're using open source Cloud Foundry, then you really want to stick to the Bosch releases and do these deployments through the Bosch command line and interface with the Bosch director. But if you're using Tanzu, then you have the option to use Opsman, right? So that a lot of the deployments are going to be through tiles, which is frankly just easier. But yeah, essentially the integration should function exactly the same, and you'll have the same experience within Datadog.
Great. Looks like we've got one more question here. Does Datadog support other container runtimes on CF besides Garden, Docker, for example?
Yeah. So obviously the Garden runtime is probably the most popular when you're running Cloud Foundry, but we do have some customers who are running Docker containers on Cloud Foundry as well, or even just like in general, right? Either their Kubernetes deployments or whatever. And yeah, the integration does support different runtimes. You might have to install separate integrations to augment that. So what I mean by that is if you're running Docker containers, then you might want to set up the Docker integration in your application manifests. And if you're running obviously Kubernetes, then it's a completely different integration. But we should support other runtimes besides the Garden ones, yes.
All right. Well, if there are no other questions, which it looks like there are not, I'll just thank Andrew and Dhruv and Datadog for hosting this webinar. And yeah, it's been really informative. I've enjoyed it. I learned some things, so that's great. Thank you everyone for joining as well. This will be posted on YouTube sometime next week. And yeah, thanks so much, everyone.
Thanks, everyone.
Cheers.
Have a great day. Thanks, Chris. Bye-bye.